Hello, today is lesson 2.7. We are beginning Unit C. Today we're going to graph absolute value functions, and the next couple days we're going to graph quadratic functions. An absolute value function is defined as f of x equals the absolute value of x, which equals x if x is positive, 0 if x is 0, and negative x if x is negative. The parent function of the graph looks like this picture below. We have the vertex, which is the highest or lowest point of a graph, is 0, 0. And to the left of the graph, we have the equation y equals negative x, and to the right of the graph, we have the equation y equals x. We're going to talk about transformations with respect to this parent graph. This is going to make more sense too when I go ahead and do an example. We actually graph by hand and we can see the shift. Okay, a transformation changes a graph's size, shape, position, or orientation. A translation is a transformation that shifts a graph left to right, up and down, horizontally, and or vertically, but it does not change its size, shape, or orientation. So the graph of y equals absolute value of x minus h plus x is the graph of our parent function, which was above, translated h units horizontally and k units vertically. Here's what you need to remember, that inside the absolute value sign, the original equation has a minus sign, and outside of it, it has a positive sign. So when we're making our shift, we're going to change what's on the inside and keep what's on the outside. And you'll hear me refer to that. You'll be able to tell what the vertex is just by looking at it, by taking the h and k out. And like I said, in a second, when we go ahead and do an example, we'll keep talking about this and you'll understand what I'm talking about with respect to all of these definitions. Okay, so here's the steps to graphing. Identify and plot the vertex. That's step 1. So in this case, I don't see a shift. So I know that my vertex is 0, 0. So my vertex in this problem is 0, 0. So I'm going to go ahead and plot 0, 0. Then you're going to pick an x value and plug it into the absolute value equation. This will give you a y value, and now you can plot the point. So what I usually do is I like to pick 2 or 3 points, and I'm going to stick wherever the vertex is. I'm going to decide, do I want to stick to the right of that or to the left of that? In this case, I'm going to do the right because that will be all positive numbers. So I'm going to plug in 1, 2, and 3. When I plug each of these in, look what you'll get. The absolute value of 1 is 1. The absolute value of 2 is 2, and the absolute value of 3 is 3. So I'm going to plot these points, 1, 1, 2, 2, 3, 3, and I'm going to go ahead and draw my line. Now, to get the other half of the graph, we are going to reflect it over what we call the axis of symmetry. The axis of symmetry is a vertical line that goes through the vertex. So if I reflect this point, this was 1 to the right, so I'm going to go 1 to the left. This one is 2 to the right, so I'm going to go 2 to the left. 3 to the right, so I'm going to go 3 to the left, and I'm going to go ahead and connect my other point. Now, let's take a look at this next problem so you can see some shifts. You're first going to pull out the vertex. The vertex is -4 and -2. Now, how did I get that? Remember, our original equation has the absolute value of x minus h. So what would h be if inside it's a positive 4? It would be the opposite, so it would be -4. And then our k is exactly what we see, so -2. Go ahead and plot this point, -4, -2. I'm going to draw my axis of symmetry, and I'm going to pick a couple points to plug in. Now, I'm going to pick points that are to the right of this axis of symmetry. So maybe I'll take -2 and I'll plug it in, and then maybe I'll take 0 and plug it in. So when I put -2 in, -2 plus 4 is 2, absolute value of 2 is 2, 2 minus 2 is 0. Then I'm going to plug 0 in, 0 plus 4 is 4, absolute value of 4 is 4, and 4 minus 2 is 2. So go ahead and plot these points. So we have -2, 0, and 0, 2. I'm going to reflect these 2 points. So this one is 1 over, do 1 over. This is 1, 2, 3 over, 1, 2, 3 over. It would be a little more helpful if my axis of symmetry was straight. So here is my new graph. Now, if we look at number 3 below, which you can't see, I want to show these graphs. It says to compare the 2 graphs. This is our parent function. This is our translation. So what happened? Our vertex was shifted left 4 units and down 2 units. Now, I didn't need the graph to do that. I can do that by just understanding what the vertex is. Left 4, down 2. Okay, I want you to take a minute to pause the video and try graphing this one on your own. Do not come to class with a blank tomorrow. You're going to plot the vertex, then you're going to make your XY chart, and in your XY chart, I want to see at least 2 X's. I want you to pick 2 points, and I want you to reflect it over, so your graph will have a total of 5 points. 2 that you picked, 2 that you reflected, and the vertex. Okay, moving on. Now we're going to throw in an A. We're going to talk about stretches and shrinks. Our graph getting narrower or wider. So we're going to throw A into the equation, which is going to be in front of the absolute value. So when the absolute value of A is not equal to 1, the graph of A, absolute value of X, is a vertical stretch or a vertical shrink. So this is narrower. A vertical stretch is narrower. A vertical shrink is getting wider of our original parent graph, the graph that we just had in number 1 above and the graph on the front page of the notes. When A is negative, y equals A of the absolute value of X is a reflection. So when it's been reflected, it means it's flipped down, it's opening down. So let's go ahead and just get started with these 2 problems so you can see what I'm talking about. Okay, the first one, we just have a half. We're still going to go through our steps of graphing. We're going to take out the vertex. So the vertex is 0, 0. You're still going to make your XY chart. Now, when I make my XY chart, I like to pick numbers that I know are going to be divisible by 2 because I can see I have to multiply my answer by a half. So I'm going to do 2 and 4. So plot 0, 0. Here's your axis of symmetry. Plug 2 in. Absolute value of 2 is 2. 1/2 of 2 is 1. Absolute value of 4 is 4. 1/2 of 4 is 2. So we're going to go ahead and plot 2, 1 and 4, 2. And I'm going to reflect those. Now, look how wide this V is. This would be called, we would say that this graph is vertically shrunk. So it's gotten wider. Okay, now let's go ahead and do this problem. We're going to pull out the vertex, opposite of what you see on the inside, exactly what you see on the outside. So our vertex is 1, 3, 1, 1, 2, 3. Here's our axis of symmetry. Now I'm going to pick 2 X values that are to the right of this line. So I'm going to go ahead and pick 2 and 3. That's fine, 2 and 3. So let's go ahead and plug 2 in. So 2 minus 1 is 1. The absolute value of 1 is 1. Times negative 2 is negative 2. Plus 3 is positive 1. So I have 2, 1. And then I'm going to plug 3 in. So 3 minus 1 is 2. Times negative 2 is negative 4. That would be a negative 1. So I have 1, 2, 3, negative 1. We're going to reflect those. Now look at how this is opening. This is opening down. I want you to be able to tell that just by looking at this equation. The negative means that the V is opening down. The 1, 3 is a shift from the vertex. So we shift 1 right, up 3. And the 2 means it's actually a little narrower because the 2 is bigger than 0, or excuse me, greater than 1. When the A is between 0 and 1, it gets wider. I forgot to talk about that, and that was in this chart here. But we'll keep talking about it as we practice problems, and you'll notice that that will be what happens. Okay, so when it says compare the graph, we're going to do exactly what I just talked about. So this one, we're going to say it's wider than our parent function. This one is narrower, reflected, and shifted. Shifted, exactly what I just said. Shifted right 1 and up 3. Okay, I want you to pause the video and I want you to try the second you try on your own. You're going to pull out the vertex. You're going to make an XY chart. You're going to pick 2 points, and you're going to reflect those 2 points. So again, I'm going to see the vertex. I'm going to see your XY chart, and on the graph, I'm going to see 5 points. Okay, lastly, now that we have a visual representation of what was happening in our graphs, we're going to just talk about them looking at the equations. Okay, we have our parent graph. Remember what our parent graph looks like, and the only thing different is this 1/4. So when A is between 0 and 1, it's wider. So the only thing that happens on number 1 is it's a wider graph. Number 2, we have a couple things happening. We have a negative, which means reflected. So it's opening down. We have a 3, which is greater than 1. That means our A is greater than 1. So it's narrower, thinner. It's getting stretched. And then we have a shift. We have the vertex is -1, -2. So we shift left 1 and down 2. Okay, I would like you to try this last you try on your own. You're going to do exactly what I did above. I don't want to see it blank. I want to see some answers here. We notice we have a 1/2. We notice we have a -5 and a +3. And then at the bottom, this is just a summary of all the different translations or transformations that happen with an absolute value graph. If you have any questions, comments, or concerns, go ahead, write it at the bottom of the paper, and I will see you tomorrow in class.